Welcome to Devlog 1 of OpenPong, and today I'm going to be covering over the frame buffer object, which allows us to have post-processing, some tone mapping, gamma correction, and covering some bloom. Before we go off into the details, I'd like to talk about the FBO for a bit. The FBO helps users render objects off-screen. This is mostly used for textures and post-processing, most likely bloom, highlighting textures, and frame buffers are just a lot of buffers like stencil buffers, which highlights and outlines objects, and many more stuffed into one neat sandwich. And basically what I've done, I've made a frame buffer to be able to use bloom in my game, and frame buffers render after the object, so it doesn't get in the way of rendering the models or rendering the textures. Since bloom is an important aspect of this video, I'm going to be talking about it in video games, how it's potentially overused, how it's important in visual lighting, effects, and how I'm going to implement it in my own program. Bloom is used when there's an overwhelming amount of light hitting the camera. Now this also works for real life with normal cameras, but in video games, sometimes they ramp it up a bit more. In some video games, the effect can be absolutely terrible and disgusting, overwhelming the viewer with way more light than that needs to be shown. Usually bad bloom effects are a symptom of old games, but there's some really bad design choices, such as in the game Syndicate, which I've just shown. The lights in that game are just way too bright and too much bloom to the point where it's overbearing. Players even made their own mods de-bloom the game, and that shows how ugly bloom can be if used incorrectly. Now what I'm going to do to implement bloom into my game engine is quite different to how video games do it. It's pretty primitive, but since it's a Pong game, it's not going to be that advanced, so why not? Here you can see that we take the original texture, get the bright parts out, and highlight it a little bit. Then we blur the highlighted bits of the texture, then we combine it, and voila, bloom. Simple. Although, it was way harder than I thought it was gonna be.
In the end, I managed to make a basic enough bloom system that worked pretty well, but there were still some quite interesting artifacts happening, and I still needed to add a few more fixes to it. Tone mapping is a simple process which recreates HDR type lighting in non-HDR screens. The values of color in OpenGL range from 0 to 1, whilst the value of HDR colors range from 0 to, well, infinity. This can be achieved with a calculation in the fragment shader file for the FBO. The exposure value here basically tells how much light we want to let into the camera. The higher the value, the more light will go into the scene. As for gamma correction, in OpenGL, the colors you input is the colors you output. Unfortunately for real-life monitors, it's slightly different, which makes the gamma line look like this. To get gamma correction to work, we need to make the inverse of the monitor gamma line. In OpenGL, we can implement this easily with the OpenGL function GL-enable frame buffer sRGB, but sometimes you want a little bit more control. All I needed to do was add another simple calculation to my frame buffer frag shader, and I was done. Although I had one more little thing to do. I had to change every texture to sRGB, or else the colors would be washed up and quite nasty. So yeah, that's it. Thanks for watching my first devlog. I hope it wasn't too bad, and I'll see you next time. Don't forget to check out my blog in the description if you want to see more written content.